Good morning. How's everyone doing? I thought how remarkable it was that here we are educators and we're sitting right amidst all of these students swirling around us. That was very, very cool. So hopefully, they'll come back. I guess they all went to class, but they'll be back. How many of you have seen the movie Robots? It's an animated movie for kids. Robots, right? In the movie, there's this robot. His name is Big Weld, and he sort of like runs a company. And he has this saying, and it's see a need, fill a need. And so in the engineering area, we try to get our students to understand that concept. I mean, eventually, engineers are problem solvers, and we want the engineering students to go out into the community and go out into the world and help them solve their problems. So see a need, fill a need. So about 15 years ago, speaking of what was going on 15 years ago, in the Department of Engineering, we constituted this concept called design of experiments, and the many of you that are educators, you give your students an assignment and you say, okay, go do this. And we turned that on its head and we said, okay, we're going to present a concept or a theory to a student, and then we're going to say, how do you prove or disprove this? How do you get the student more involved in the process of education? There are things that I'm going to talk about in the very brief time that I have about how we get students involved in dictating or designating their own education, their own future, their own progress. And the first place it starts is with their education. So instead of giving them an assignment and saying, go do this, we give them a theory or concept, and this works for any subject, not just engineering or science. And we say, now, how do you go prove or disprove this? And we called that design of experiments. And so we were content to go along with that for about 10 years. And then we were very fortunate to have an industry specialist come in from the outside, a former chief information officer for AT&T and IBM, is a gentleman named Jean-Jacques Ramon. And he came to the department, he said, I would like to ask if you could have your students help do some research for the Swiss government. And the research was with regards to autonomous independent weather stations out in the Alps, and having quadrotors go to these weather stations and using wide area networking, communicate with them and bring the information back so that they could predict when there would be landslides. And I kind of looked at him like, never tried something like that before. What are you suggesting? And what he was suggesting is that our students would do the research. The students would suddenly go from classroom activities to real undergraduate research. And so the topic of my very brief discussion here is undergraduate research. Developing concepts, developing ideas, taking them out to the world, not just staying in the classroom, and then trying to promote to the students entrepreneurial behavior. So the first stop on our voyage, I guess, was Quad Forge Quadrotor research and development, and the areas of research that we've done is remote weather station that I was describing to you, remote weather station access, and that's purely autonomous. It's wide area network related. And you're like, well, what did you have to start with? We had nothing. It's like, well, what are we going to do this with? You're going to do it with quadrotors. What are those? And then how are you going to recruit your students? So this isn't a classroom activity, and that's the whole point. We're trying to get students to see a need, fill a need, and not necessarily something that you teach in the classroom. So you have to engage the student. You have to encourage the student to get involved in class and outside of class, and design of experiments and research projects. And so in order for us to really make this thing go, we needed a research course. So we instituted EGR 291 and 292, which is Engineering Research 1 and 2, and you don't typically see that at this level. And not only do we do that here, but it's also being done at North Penn High School, so they do research in quadrotor technology. See, you could do research in middle school. You could do research in elementary school, if you were so inclined. Also, speaking of farming, right, we also do quadrotor research in the areas of mining and farming, and also real estate and emergency services, and it's all associated with this one large research program. And we said, well, what else can we do? Where are there other needs? There are needs in the energy sector, there are needs in the transportation sector, eventually we'll run out of fossil fuels, and we need to address that. So for a number of years now, we've been looking at, I'm sorry, I jumped ahead of myself here. I need to mention that last year we were incorporated into Temple University, Penn State University, and the Air Force Academy out in Colorado, and some other institutions are all involved in a larger NASA research program. And we have a NASA research lab in our engineering spaces, which is shared with our quadrotor team, and they do nano coatings research. So they take flight instrumentation that's used on our quadrotors, and we nano coat it so that it can fly in the open. So, you know, I guess you guys would probably, if you ever dropped your cell phone into the ocean or dropped it into a body of water or something like that, you know, there goes that. Well, not anymore. There are services that'll provide that for you, for your coatings for your phone, but we're coating electronics, we're coating control electronics and quadrotors so that they'll fly in the rain, and we're partnering on some research with Temple for the Navy and NASA, and it's very, very cool stuff. But what does that do for the student? That allows them to see a need, to fill a need, but in addition to that, it allows the student to get involved in higher level research, the undergraduate level. That gets them networking, that gets them internships, that gets them out in the world, and that's the kind of thing that we need to be thinking about in the classroom. It takes them outside of the classroom. So these are just some pictures of the research that's being done by the students with the nano coating for the NASA program. That's one of our prototype quadrotors, and as I mentioned to you, we design our own quadrotors, and then we build them with 3D printing technology, and we customize the control software, we customize the electronics control hardware. They build their own flight platforms. This is one of our test rigs that now Temple University is going to be adopting from us. We use it for motors prop research to find out how to optimize the best motor prop combination, and our students have been working on that for about a year now. Temple's really excited about getting that test rig. They're going to build their own. This is the research lab for the Quad Forge Research Lab, and also the NASA Research Lab. And then, so as I mentioned, what are some of the other areas of need that we're trying to introduce to the students? One is energy, and one is transportation. And so in the spirit of addressing transportation needs that are looming, we decided that we wanted to build ourselves an ultralight vehicle that was hydrogen fuel cell powered, because electricity and hydrogen are the areas that will be most heavily researched going forward, especially once we run out of fossil fuels. So we designed a vehicle, and then we said, well, how can we take this out to the community? How can we get the community engaged, get more students engaged in the concerns about transportation? I don't know how you feel about it, but if I could go outside and know there's not millions and millions of cars pumping noxious gases into the atmosphere, that would be fantastic. Go out, take a big, deep breath of air and go, wow, fresh air, what's that like? So the concept is to try to get away from internal combustion engines, and we built designed for ourselves an urban concept vehicle, which we compete at the Shell Echo Marathon. This year it's going to be in Detroit again. They do this in Asia, they do it in Europe, and they also do it in the Americas. This was original prototype. Students brainstormed this idea and designed it using 3D solid modeling software. This is the actual implementation. It never quite looks like it does on the computer. And you get this, and well, okay, it's not quite the same. But it's pretty advanced, especially at the level that we're working at undergraduate level. And that's our team, or several members of our team. We take this vehicle out on the road into the community to introduce to students what you can do at this level. And then these are just some of the other areas where we saw a need and we fill a need. Students work on these projects in the Student Engineering Association. They also work on them in the research classes. They work on them in their classes. We cross-pollinate between classes so that we can achieve the most progress. And so I'll just walk through these. The Student Engineering Association was working on a prosthetic hand and identifying potential candidates, both ex-military and also people with genetic defects and injuries and what have you. And then also wheel motor design, the idea that the motor's not in the front of the car, the motor's actually in the wheel, and it creates tremendous efficiencies that way. We also do some custom work for individuals that come to the college and say, we have a need, can you help us fill it? So that's a custom engine mount actually for a motorcycle. And then that's a pie case, so somebody may buy themselves a pie control board, and then we would design the pie case and print it out on our 3D printers. We also have lathes and mills, and we've got some tremendous stuff thanks to the Perkins organization. That's a squirrel-proof bird feeder. So we have had students in some of our engineering classes that design product, and they go out and then they try to patent it and they try to start business. We've had students start businesses. We've had students apply for patents, and it's just a tremendous, tremendous experience for us all. So again, we're trying to promote see a need and fill a need. Thank you for your time.
Yes.